Hello, morning. Good morning. Let's see, I'm just going to share the thing. Ugh. By the way, I should subscribe to Code Sandbox. There we go. Go. Hello, morning. And then close this, and I need some music in the background. And then, let's do some 90s hits. Okay, cool. Yes, I've been working on something. I'm actually going to fix a bug here. And then I can talk more about it. Maybe I'll talk about it while I'm working on it. Let's see. The thing that's going wrong is that, yeah, actually I implemented it the wrong way. Oh, wait, it isn't here. It's my personal account. There we go. Yeah, like whenever I learn something new about state management, I tend to build a library out of it. And that's the case now as well. And it's not because I want to create a state management library and make it a thing for people. It's just a way for me to summarize my learnings. And let's see, let's work on this bug first, because I think I just completely implemented it. It's so annoying that I can't play music while I'm streaming. It has this weird noises. Hello. I have to turn off the music. I need some music. Where should I get my music from? I think I actually have to use my phone because I can't concentrate without music. So let's see. Yeah, let's do that. Okay, cool. So we have something called observable computed state, and I did something bad here. Let's see. So first of all, I think I should create a private compute function, and it basically just does this, and then we're going to, yeah, this is the tricky thing. I have this thing that needs to run with super, but I also want to assign something before that. So yeah, I guess it's okay to do. This is how it really should work. Why the hell? Oh yeah, sorry. Compute. So this is how it should work, but for some reason I'm getting errors. So if I run this now, so this would be observable computed state. I think it just completely hangs. Yeah, see that? I get into a circular thing, and I don't understand why. Because what happens here is I'm passing in a compute function. So the test looks like this. I'm just passing in a compute function where I grab some state from this observable state, and then this getter tracks, knows that it's computing. So it adds the observable state to an array, which is this thing, this here, global computing context. That's the empty array. And then we run the function, which now the getter on the observable state is pushed into this array. I remove the global context, and then I have my thing here. So here we can see I did push my observable state in there, and there's no more subscribers. Oh, sorry. Yeah, that's subscribers on. Yeah, that doesn't matter. But then I just want to map over all the observable state that was used and subscribe to it. And then whenever it changes, I just run this compute again. But for some reason, it goes into loop. I don't understand how that looping mechanism can happen. But it doesn't matter. Like, I can just do compute. I don't even need the complexity of setting the value. Like, even here it goes into loop. I don't understand how that's possible. What if I just do ST? What if I just do that and then we compute? Like, I'm wondering if it's like something related to classes or something. No, it still goes into loop. Damn it, I thought I had the answer. No, I work on I don't work in Notepad, no. I work on using Code Sandbox. So this is what we call a cloud sandbox. Wait, well, now I'm in my repository. So this is a repository, but the app I'm using this library for, that's the cloud sandbox. But both of them are running on like these micro VMs that's powering the infrastructure of Code Sandbox. What the hell? What the hell? How can this cause a loop? And then even if I do this, like I thought I would be able to just... So it doesn't even have to be 2. It can just be like that. Now it throws. And looking at the stack trace, it's like it doesn't even... Like it just sets the state. Oh wait, is it because the initial private? No, I don't understand this. How is it possible that it goes into loop? Because it calls it, yeah, let's change this. So it computes it the first time and it just returns the value. So the thing that triggers it, it's that I'm changing the state of the first one. So if I do this, it's fine. Though the test fails. But so this runs through, this compute runs once. And what happens is that it collects this other observable state, it subscribes to it, and everything's good. So if I log computing disposers, that should hold like 1 disposable subscription. And it does. And then I set the state of this observable and it triggers the subscription. Which triggers this one, which triggers compute once more. I'm disposing of existing subscriptions. I'm creating a new context. I run the compute function again. And I get the thing. And then the same thing should happen. What's interesting though is I'm returning a value here the first time. I don't understand it. How can it cause a loop? Okay, so the count is 0. I'm going through here. Yeah, no, it should be at 2. What I don't understand, like, oh, God damn it. But it does say notify disposing. So there's something calling this notify. And where is that coming from? 109. Like it has to come from here, right? 68, 98. Yeah, 68. So this is where the test is setting the thing. And then we reach line 10. Yeah, goes through the subscribers, goes through the set. This is what I don't understand. Like the stack trace says that it's coming from the test, as if the test is running multiple times. It's not the compute function, it's like the whole freaking test. That doesn't make sense to me. Constructor. Like there should only be disposing. Yeah, but that's the thing. The constructor doesn't run multiple times. That runs one time. So here it goes in, it runs the compute, returns the value, then it notifies because I set the thing. So this is what we're seeing here. This is the notify that's happening up there. Okay, so maybe I need to, should it be 2? So the count is currently, no, because it should only trigger once. That's what I don't understand either. So notify disposing. Yeah, so here it is, like now it's suddenly disposing again. We notify, it's disposing. And then it should have stopped here. But for some reason, it runs again. How can it run again? It's almost like it's calling compute again. Set for each. It notifies. It goes in here. It calls compute. But we don't have any other computes here. This makes no sense to me. Like even if I set, I'm wondering if I'm not going through it enough times. Like even if I say count 3, it's almost like it's a new execution context. Because you see this, it's the exact same stack trace. But now I've gone through it 3 times. You see, the stack trace is exactly the same, but now we've gone through it 3 times, and that But now you see it's longer, right? So it's notifies, disposing, and then disposing. But it still gives the same freaking stack trace. So it's almost like it's going through the whole test twice. Which makes absolutely no sense. I wonder if it's something related to like the order of things here. What if I call super first? Super. Oops. Oh, that's actually it. I think. Yeah. No. Wait a minute. Clear. No, it's doing the same. Wait a minute. Is it the getter that's doing it, not the setter? No, it's still running through it multiple times. So if I do this, we don't get the error. Yeah, exactly. Okay, so it's definitely this thing that's causing it. I'm just don't understand how it's possible. Okay, I'm going to try another thing, and that is to set a timeout for this. So we'll return new promise. Then, sorry, I can do promise resolve. So we're not going to do it synchronously. We're going to, because I think, oh, this makes me think. I think I actually know that this is an issue. I've implemented this kind of functionality before. No, that didn't help. Fuck, how the hell does this go in a loop? Like it literally is going in a loop, but this is only triggered once. That's the thing. Constructor notify. You see this? There's a single notify. And then it's disposing, and then it's disposing again without a notify. How is that possible? Like the only way it can calling compute again. So this is the thing. I got notify and calling compute again. We're disposing of the subscriber. And then it says calling compute again. But it didn't come from a notify. How can it run this code without being run by a notify. The only thing that can trigger this callback is a notify. Like, this is literally where it calls a subscriber. I'm so confused. I'm so confused by this. And if I, like when I throw, oh, wait a minute. So let's do this. Instead, let's throw inside here. Yeah, because that's where it's triggering. It's not here, it's there, I think. Okay, so where is this coming from? And it says it's coming from notify. Calling compute again, calling compute again. And it says it's coming from... Oh, is it like... Because, wait a minute. Oh, wait a minute. Oh, I think I know what's happening. Oh my God. So we're doing a for each here. And then it hits the first one, which actually calls it, but then it hits this one. It disposes of it. And then the for each continues. Oh, this is interesting because it's added again. And then the for each continues and calls it the next. That's what's happening. Wow, shit. That is fascinating. So, wow, that is insane. So what we need to do to actually make this work, subscribers, is array from this.subscribers, current subscriber. So if new subscribers are added, we're not calling them again, especially not the same one. Wow. Okay, I don't think it will fail now. Yeah, you see that? It worked. Wow. We want to make sure that we do not doing a for each on a set might iterate. I don't want to. How do I explain this? Therefore, when calling subscribers, they might be removed, added again. So we want to make sure we only notify during the for each of the set. Wow. So we want to make sure we only notify the current subscribers. Wow, that's an interesting one. Okay, so let's remove all these logs. And let's revert this to the thing we had. Supercompute, and this one, we don't need all this stuff. What do we want? We don't need that value. We're just going to recompute it by setting this. Let's remove this. Yeah, because in my mind this should have worked. That's why I was so confused, because it was very straightforward. But of course, when you're synchronously changing a set while it's iterating and then it starts iterating the new stuff, it fails. Yeah. Okay, cool. So now we have a test for that one. Let's move into yarn test watch mode. Yeah, and this doesn't need to be a promise anymore. Oh, where am I logging that? Nice. Okay, so we're back on track. Should update from other observable state. Should compute from other observable state and update. Nice. Which it does now, and it should also support like an observable computed can observe another observable computed, and so on. And you might wonder, like, if you know MobX, and like there's been tons of libraries that does observables in some fashion. But what I'm doing here, I'm thinking about the observables from like from the imperative object-oriented way of programming first and foremost, and then thinking React second. But I want to have like a really good bridge between the imperative world, doing that right, and also making it easy to consume in React. So I'm going to show in an actual app here, but let's see. I don't want to go completely overboard with the tests here. I'm just going to make sure that they work. So we have observable subscription. Observable subscription test. Oh. So an observable subscription. So this is the thing about one thing is like binding the imperative world of like classes to React and making a value observable, but there's also a lot of other asynchronous stuff that you want to sync with your UI. So one thing would be a subscription. So a subscription in this case is a subscription that is an observable that has a value, but the way the value changes is by a subscription. It's not something you change manually. Should have initial value. Observable subscription. So this takes an initial value, so for example 0, and then it has a subscription function which has a disposer. So we're just going to create something silly. So this is just to subscription. So here you always have a value, but then what we can do, it should update the value. So what we can do here is, well, I guess we can basically just set a timeout. How should we do that? Yeah, I think we'll just create like a sleep here, because we're dealing with yeah, let's new file utils export const sleep, set timeout, duration, number, sorry, new promise, resolve, set timeout, resolve, and then duration. So let's sleep for like, well, I can just sleep 0 in this case, and then we're going to, we get a way to update there. So we can say update to the value 1. And then what we can do here is, let's make it async. Yeah, this can't be async. And then we'll await a sleep of well, this one runs first, so it should be enough with a 0 there, and then this should change to 1. Yeah, cool. And then what's also cool about this is that it actually it takes a third option. Should update only with a subscriber. So that means if I say true here, this test should fail because there aren't any subscribers here yet. So it won't actually run the subscription. So we're going to await, and then we're going to expect it to still be 0. And then we're going to subscribe to this subscription. And then we are going to wait yet again, and then it should actually have. Oh, was it just, what happened there? Was there an actual problem? Wait, what happened? Type error. Where? What's the type error? It's not. Why are you complaining? Where are you saying it's a type error? Is it because I'm calling super from okay, what if I do this and then I say, oh, then it actually fails? Yeah. Oh, I see. I'm not sure if this actually works. So what I think I need to do is, so we're going to say const subscribe equals this dot subscribe, because I want them to be instance members, because I want them to always reference, I'll show you later, they should always reference its own thing, because it has to do with instantiation, but then we can rather do this. And then we'll, yeah, I think that should work. Yeah. Cool. Yeah, and this one works, so now that one's done. Let's see if we can move through this quickly. Yeah, and then we have observable promise, which is interesting. Well, we don't have to write all the tests. I kind of want to see how this looks like. Yeah, let's wait until I actually start using these things. But what we should do is update the documentation, because it's changed a bit. Yeah, so what's interesting here that I changed is now it should always be private. Like, this has to do with proper imperative object-oriented class-based programming. Is you should never expose a setter so that anything can change the internal state of this counter. So what I've done is that all these primitives, they are to be instantiated privately. And then if you want to expose something outside, you can do for example, if I want to subscribe to change of the count, I could do on count and I would say this count subscribe. That's why I want it to be an instance member so that I can do this. And what's kind of nice about this is that I can say use count, and then I can say count use. And this is actually a React hook. So this would be a public thing for typically for other parts of the imperative code, but you can also expose these React specific things. So that's what these primitives are. They are async primitives you can use both in your imperative layer and you can use in your React layer. Or at least that's the thinking behind it. Anyways, and this is do I say private here? Can I say private in an interface? I don't know. Let's explore it. So we have, yeah, this is the same. Yeah, so this is an interesting one where you say private count emitter, and then when you want to do on count, you say this don't count emitter dot subscribe. Because that means that only this count emitter, you can only emit privately in the counter, but you can listen to it publicly. And this is really important. Yeah, we could even do like private here. And you would do like get yeah, so you would do something like sorry, and then you would have get count would be return this count. Like this is how you do proper separation, so not so that you can't like change stuff all over the place, or at least you get that guarantee. Yeah, and you can argue like why add this why is it worth it? Like adding, like even just having the concept of private and public. And yeah, it definitely makes sense in bigger teams and bigger apps, but in smaller ones, you probably wouldn't have any issues with it. But having like a concept, a thinking around what part of the code should execute what's the responsibilities of the different parts of the code, that's also what it expresses. Like what happens inside this class and what can happen outside of this class. How can you interact with this class? And it doesn't have to be a class, it just have to be a concept. And that kind of thinking is really important to describe what your app is about. So yeah, so what I want to change here is yeah, so I want to change, oh yeah, sorry, so I didn't do that here actually. So that would be use count would be this.count.use. And then you say use count. yeah, so the only thing I don't like about this from the previous example is that you could just create count and then you could use it. But then you could also just set it from the outside, which is not what we want. So there's an additional overhead to expose these things, but it guarantees what can happen inside the class and what can be consumed outside the class. So yeah, again, you can argue, is it worth it? But at least that's been my reflections around why I built this thing to summarize all my thinking around this. So you can imagine like you have a class that has like maybe 5 different properties to it, like a name, title, whatever. You would have to like create 2 properties for each of them. One to define its internal changing of the value, and then you would have one for exposing to consume the value. And then not only that, if you wanted to publicly just allow it to because I didn't, and then if you want to, for example, okay, so let's just talk about this counter. So now I've created a count inside this and I'm allowing React to consume it efficiently. But what if I wanted some other class to also be able to use this count? Well, then I would have to create like a getter. Well, not necessarily getter, but get count. And I would say return this count get. So you see this, you kind of get a lot of overhead with this approach, but it does enforce the separation. It's interesting. Because the thing is that for each of these observables, there's like there are like 3 ways I want to consume them. Either by getting the value, subscribe to the value, or use the value. That's the React context. And all of them kind of has this. So that's why it feels so weird to like on count, this count, subscribe. Like you have to define these 3 for every single observable state you define. That being a pure observable state or like a subscription or promise or whatever, you have to define these 3. And I don't like that. I don't like that. I wish I could separate it in a different way, or at least make this the default. So you would kind of just say, so maybe you would have like a private count, and then you would have a count which is this count dot. What is this? It's kind of the public part of it. But this is the core of asynchronous programming, especially when you have a view layer that you want to simplify the consumption with, is that you can just get the latest value, you can subscribe to new values, and then in terms of React, you can also subscribe and like sync the value with state in React for UI consumption. And it would be the same for Vue or Angular or whatever. It's all subscription based. But the point is that for this count, for example, I never, like, I only really need it for React. So yeah, I would really only do this. I don't have any other logic that requires access to the count. So maybe that's a good thing, is that you actually explicitly define it, because it also describes how that value is actually consumed. Yeah, it's interesting. Okay, let's just try this. Blah, blah, blah. Yeah, let's just do that. Oh yeah, let's use count equals this count dot use. So the counter use count. Yeah, so this is the dependency injection. This is really just to bring in another aspect of imperative object-oriented. Well, I guess you say object-oriented programming. Is that you never consume implementations, you consume interfaces. So with dependency injection, we define an interface for our app, and then we implement classes for those interfaces, and then you consume the interface, and then you provide the implementation for those interfaces, and that allows you to more efficiently write tests. You can build a whole application as just a sandbox implementation of the classes, which makes you move really, really fast. And then you rather implement the proper classes when you know exactly how you want this to work. Let's see. Okay, dependency injection is the same. So this was observable. Yeah, so let's just don't do that part of it. And this is not really, like, it's not supposed to, emitters is really here for on our emitter. It's not really meant to be used to use values, because you have the observable state, so you have everything included. So this will be more like where you actually want to emit events. Something async. Hei, hjelp meg. Har du spist for mye godteri da?
Ja, men jeg spart litt.
Du må ikke spise så mye, vet du. Gleder du deg til å prøve? Ja, laste en oppdatering.
Tar det lang tid?
Nei. Det gikk kjempefort.
Når det oppdaterer seg, er det Emma eller pappa?
Emma. Se, kan du velge. Musikk også. Kan du velge hvilken du vil prøve?
Den.
Ja.
Nå vet jeg hvordan man spiller.
Nei, men det er jo akkurat det samme. Det får du til.
Hvis jeg sitter her
Mhm. Eller så har du en godstolen har du inne på rommet ditt da. Men hvis det er greit å sitte der, så... Jeg prater litt, for jeg holder på... Går det bra?
Nei, jeg vet ikke helt hva jeg skal gjøre.
Skal jeg starte det for deg? Nei, du startet det, ja da.
Ja.
You're right. Okay, so this is more for just emitting events. But you can also use this. So you can have on error, but you can also do... What would we call this? Use on error? Maybe this doesn't... Like, the thing is, this is just an effect. Yeah, but I think it's okay. Just playing around with this, so it doesn't matter. Subscribe to the emitted event. Is in React component. Okay, so we have this thing. Maybe we should just... I don't need to fix everything. Let's just fix this one and then... No, this is promise, so let's just... Okay, let's just publish this so we can actually write some code. Let's do that. Let's commit and push it. Let's see if we can publish it. OTP. Do you have my auth? I have it on my watch. I think I have it here. Auth in, there we are. Ignore. There we go. And then we can move over here and we can update to the new version. Let's see, impact app 2, and let's yarn install. Okay, so let's look at the interface first. Yeah, I don't want to call this DI. I want to call it the interface. Rename to interface. I guess now everything breaks. Oh. Did it actually change them? Oh, that's weird. Yeah, that one's wrong still. I haven't implemented that. App TSX. Okay, cool. It's running again, but let's look at the implementation. So, first of all, can I say no? You don't use. Yep. You don't care about that in interfaces. That's okay. So here I want to say that this state is actually private. Oh, yeah, exactly. Oh, okay. So what do I actually want to do here? I want you to be able to subscribe. Oh, this is interesting. So I really just want you to be able to... how do I, yeah, what do I actually want to be able to do here? Well, currently I don't want you to do anything with this. So let's just forget about that. But let's look at iTodos. Oh, this is interesting. So what I really want you to do here is yeah. What does this mean? So we don't really have to-dos here. I really just have use to-dos, which would be this. So the interface just guarantees that you are able to use to-dos, and that you can add a to-do. Yeah, this isn't working out exactly how I hoped. Yeah, I don't like this. I like the previous version where it all was public. This is too much orchestration. I wonder if there's a way to The reason I started thinking about this is because when you have an event emitter, for example, if you don't separate its private emitting from its public subscription, it means that anyone can emit an event on that emitter, but it shouldn't. Like, it's private, the emitting. But that's also true for this. Like, you could say that you can make all your properties public, but the problem is that then you can change it from anywhere and you don't have control of that. Like, it's simple. Like, you can even inside a React component, you could just change something. But it's not. Yeah, I definitely don't like this. Yeah, how would I actually do this? You could also argue, like, why even have the hooks with the classes? Why not have the hooks separated? So you would rather give it, you would have like a use observable, and then you would give it an observable as an argument. But I really like the idea that you could just go in here. You could just grab the counter. You can say count use. Just to feel so fluid. And then you would do get somewhere else, and then you could even do set here. But it doesn't really follow this principle of private privacy. I don't know what I feel about that. So maybe we shouldn't maybe the library shouldn't make any assumptions about this. Yeah, it just makes it harder to understand. Like it still works the same way. It's just it's an option you have. Yeah, so we don't need to do any of this. Oh, yeah, that's not possible. Yeah, and the thing is, like, if you were to yeah, no, I think this makes sense. Like, you can isolate it if you want to, but you don't have to. Though then you have this case, like, this is kind of weird. Oh, this is error emitter, by the way. This is so easy to express in React. It's like you have a use effect and you just say, in this case, like something async dot on error. But still, you have this awkward, like, it's so awkward. But anyways, but maybe that is better in this case. Because React Base has an okay primitive, like use effect for doing subscriptions. It's more this consumption of external state that it doesn't have not as straightforward hooks for. But it is nice to just say use on error. But that's also the thing, like you could call it on error, right? And then you have everything. You can do on error dot subscribe, or you can do on error use. But then you also have on error emit. Like you don't want that to be public. I wish there was a way to make properties to like make a class take ownership privately of a property. But again, like how Like, how realistic is it? Yeah, and you can even call it like an error emitter. And then say error emitter, subscribe, error emitter, use, error emitter, emit. Yeah, I have to think on this. I have to think on this. Yeah, I have to go. But yeah, anyways, just playing around, thinking, reflecting. Yeah, I'm really curious about this. Like, because that's one of the most powerful things with classes is that you can actually define what's privately consumable and what's publicly consumable. And when you create instances of other stuff where everything's public, you want to separate that some of it should only be managed within the class and other things should be further exposed outside the class. And there's no good way to express that. Much easier to just make everything public. Because that's kind of the secret sauce here as well. Like, you don't want to explicitly expose like this use thing on your classes. That's weird. It's more that these objects or these instances has it. So yeah, I definitely don't like the separation. Wish there was a way to kind of revert it. So you would rather say you have an error emitter and then you would rather say private emit error. And that would be, what would that be? How would that work? Well, I guess you could, yeah, you could turn it around and then you would say emit. So that's interesting. So you could say that observable emitter, you actually make it private here. But that's kind of hacky. It's not supposed to work this way. You could also make it part of the constructor. What's responsible for yeah, no, that's weird. Yeah, I wonder how you would do this. Like, we could do this actually. Because then you have the error emitter, but then emit error is the private thing. And this works. And then you would do the same for setting new state. But then it would be for update and setting. Like, you have multiple ways to change. This is, yeah, I don't like this. It's much easier to make the whole thing private or the whole thing public. Yeah, no, I have to think about this. Okay, I have to stop. Bye for now.